Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are looking at Chapter 5, starting with 5.1, Slope, with parallel and perpendicular lines. What we will be doing is by the end of the lesson, when given two lines, you will be able to show if they are parallel, perpendicular, or neither to each other, and find the equation of those lines that are parallel, perpendicular to another given line. Why do you need to know this? Well, so you can prove the slope criteria for parallel and perpendicular lines and use them to solve geometric problems. How will you know you've mastered it? Well, you'll know you've mastered it when you can explain how to find the equation of a line and write the equation of a second line that is either parallel or perpendicular.
So go ahead and take out some colors and a straight edge, because what we're going to do next is graph all of these lines. We gave them to you in slope-intercept form, so this should be review for you guys. Slope-intercept form, remember, shows your slope-intercept, it shows your slope, which is your rise over run, and your y-intercept, which of course crosses the y-axis. So for the first one, because there is no plus b part of your equation, we know that our y-intercept is going to be 0. So we're going to put a point right on the origin. And then your slope from there, you're going to rise 1 and then run 2. So you're going to go up 1, right 2, put a dot. Up 1, right 2, put a dot. And then with your straight edge, you're going to connect it. You should end up getting a line that looks similar to the red one you can see on your screen. We're going to go through and do the same for B, C, D, and E. I'm going to go sort of quick through this, so if you need to pause the video right now to graph these a little slower, you please go ahead and do that. So the next one, we have a y-intercept of -1 and a slope of -2. So that means we're going to go down 2. The 2 is going to be over a +1 to keep that fraction negative, so we're going to go right 1, down 2, right 1, down 2, right 1. And you're going to end up with a line that looks like this orange line that you can see on your screen. For C, your y-intercept is at +1, so you're going to go up to 1 and put a dot there, put a point. And then you're going to go up 1, right 2, up 1, right 2, and you're going to end up with this yellow line. Next, you're going to go for D, you're going to go down 2, put a dot, and then your slope is going to be down 2, right 1, down 2, right 1, which is going to look like your green line you can see here. For E, you're going to go up to 2 on your y-axis, put a point. And then you're going to rise 1, run 2, rise 1, run 2, and you're going to get this blue line. And then lastly, your y-intercept of 3, so go up to 3, put a point. And then your -2 slope shows that you're going to go down 2, right 1, down 2, right 1, and you get this purple line. So you should have a set of 6 lines graphed. Ideally, they should be in different colors. So as I said, you should have your colors out showing. You can see how easy it is to color coordinate these so that you know which one is which.
A couple of other things that are important and will be important in your future math classes is that number one, anytime you are graphing something on your coordinate plane, if it is a line or if it is a parabola or really any type of graph, you always want to carry your graph to the end of the coordinate plane. So notice that our lines extend to the end of the coordinate plane.
All of the arrows are actually drawn off of the coordinate plane.
You never want to end them before. Another thing that is very helpful to your math teachers, especially when you are trying to show your graphs, is if you will write the equation of your line on the line that you are graphing, so that way it is very visual. So for example, on our blue line that you see here on our coordinate plane, you could write right over the top of it, y equals 1/2 x plus 2. So that way we know that is the equation of that line. So what we would like for you to do next is we would like for you to take a look at all of these graphs and think, like, what observations can be made about the equations and the lines of those equations. So look at the equations, look at the values in the equations, and then look at the lines, and if you would, make a conjecture or a hypothesis about why you think you see what you see.
Okay, so hopefully something that you guys have come up with is that when the coefficient is the same in front of x, so remember, a coefficient is a number in front of a variable. When they are the same, that is your slope showing the same. And if you look at all of your slopes going positive, they all are 1/2. All of your slopes going this way are all -2. What kind of lines are you seeing when you look at your graphs when this pattern is there? You should be noticing that they are parallel lines. You should have also noticed that while they're not all the same, there is similarities between them. When you're looking, the coefficient of -2 is perpendicular to a slope of +1/2. So what we can say here is that our slopes are negative reciprocals. Negative meaning one is positive and one is negative. And then reciprocals, if you remember back to, I don't know what
Seventh and eighth grade.
7th and 8th grade, reciprocals are when you take a fraction and you flip it. The numerator and denominator switch places. So what is a -2/1 flips and changes to a positive, it becomes a +1/2, which you can see those are the two slopes that we have here, and that resulted in perpendicular lines.
I like to tell my students, you need to remember that anytime you are doing perpendicular, you will always do the flipping opposite.
The flipping opposite. Flip it and then take the opposite. All right. We are going to be writing our equations in point slope form to start. This may be new for some students. Shouldn't be.
This is Algebra 1.
Some students always seem to be
I
shocked by this.
I
don't know.
I think they forget it. It's been a while.
So you can see on your screen the y minus y1 is equal to the value of m times the value of x minus x1 is your point slope form. So go ahead and fill that in after the name point slope form.
And we call it point slope form because a couple of reasons. Number one, you need a point and you need a slope. And if you'll notice, the very first thing you see in point slope form is some type of indication that we are looking for a coordinate y1. So we need a point and then a slope.
Okay, so if we go through the steps, the first thing you're going to do is to do this, as Mrs. Ness was saying, you need to know a point and you need to know a slope. So the first thing you're going to do is you're going to take the given point you're using and plug it in for your x1 and y1. The next thing you're going to do is take whatever the slope is that you have and you're going to substitute that in for m. After you do this, you will start simplifying this into either standard form or slope-intercept form. No matter what, you need to get rid of those parentheses, so you're going to distribute your slope into those parentheses. And then your last step, you are going to take whatever y1 is and add or subtract it to the opposite side, so to the right side of that equal sign. So if we were to do just an example to help you guys out to remind you how to use this, I'm just going to create an example and you can go ahead and work it out to the right of your paper. If I were to give you a point of 4, -2, and a slope of -3/4, we can go ahead and substitute in, oops, we don't want crayon, we can take our slope and plug that in for m, and we can take the 4, -2 and plug that in for our x2, y2, x1, y1.
So if you actually just follow your steps one step at a time, what we're going to do is we're going to go ahead and substitute in our x1 and our y1. So we get y minus a -2. Be very careful with that because we are substituting in a -2 into an equation that has a minus. So it's y minus a -2 is equal to m times x minus 4. Next, we're going to go ahead and substitute in our slope.
Right here, this will become positive.
We're going to go ahead and clean that up because minus a minus is plus. So we have y plus 2 is equal to -3/4 times the quantity x minus 4.
So you can see what we did here was we took the -3/4 set with our slope and plugged it in for m.
Next, we're going to go ahead and distribute our -3/4 to our x minus 4. So we get y plus 2 is equal to -3/4 x. And then don't forget, you also have to multiply that -3/4 times the -4. So think of it this way. 3/4 of 4 is 3. and we have a negative times a negative, which is a positive. Our final step, we want to go ahead and isolate y, so we're going to go ahead and subtract 2 from both sides of our equation. So we'll end up with y is equal to negative 3/4 x plus 1.
And that's what we're going to be doing on the back side of our notes, so that should again be review for you guys. So let's just recap what our formulas are. If we don't give you the actual answer for slope, here is your slope formula that you can go ahead and fill in. You need to know 2 points, and it's going to be whatever the difference of y2 and y1 is over x2 minus x1. You can see this written a couple of different ways. That is the formula. You could also see this as delta y over delta x for change in y over change in x, which is what that means.
Next, we have our slope-intercept form. In our slope-intercept form, the reason we call it slope-intercept form is we're always talking about the slope first and then the intercept where it crosses the y-axis. So our slope-intercept form, y equals mx plus b.
Where m is our slope and b is our y-intercept. All right, and then we have our point slope form, which we just talked about. Remember, with point slope form, you're given a point to use. In this case, it is x1, y1. And you have to also know your slope. So right there, x1, y1 is our ordered pair. And then, of course, m is our slope. And then last one is standard form. Standard form is ax plus by equals c. In this particular example, a, b, and c are all going to be real numbers. They must be real numbers. A cannot be negative, and no fractions. So A, B, and C cannot be fractions. They cannot, and A cannot be negative.
So basically, we want a, b, and c to all be integers, and we want a to be a non-negative. So when we say we want a, b, and c to be integers, integers are your whole numbers that are positive and negative.
Okay, so those are our formulas that we're going to use. We have 2 examples we're going to work through with you guys. So if you would please follow along with us. If you need to pause the video at any time, please go ahead and do so. So the question is saying that we're going to write a new equation for a line. The criteria for this line is that it must be parallel. Go ahead and get my highlighter going here. It must be parallel to the line I'm giving you. This is the line you're given. So
if we're thinking parallel, if we go back to the beginning of our notes and we were thinking about the lines and the equations of our lines, parallel meant what?
That those coefficients, those slopes were the same if you look back at that observation.
Oh, that's right.
So I need to be able to look at 8x plus 2y equals 8, and I need to identify what that slope is. So the first thing you always want to do with problems like this is take that given equation and convert it into slope-intercept form.
Well, why into slope-intercept form?
Because that's the form that shows you your slope.
Oh,
there you go.
Easy.
So that's why I have written over here, the first thing we're going to do is we're going to work with this equation. And we need to isolate y. So the first thing you guys are going to do is you're going to subtract that 8x out. And you're going to move it to the right side. Because 8 and negative 8x are not like terms, they have to remain separate. And I wrote the negative 8x first because y equals mx plus b, the x term goes first. Our y is still not isolated. We need to get rid of the 2 times part. So to eliminate that, we are going to divide that 2 out. And you can see now that we've isolated y, and you can easily identify your slope as -4. So now we're ready to write our new equation similar to how we did on the front side.
Well, we might want to identify some key parts. I know we're going to be using point slope form, so we're going to need a slope and a point.
Exactly. So the first thing we know is that we have a point of -1, -4. That is going to become our x1, y1. So in our formula that I have written here, that this y1 is going to go right here. and this x1 is going to go over here, and you're going to end up with an equation that looks similar to this.
Easy.
The next thing you need to look at is, again, the slope that we just found. We know that our slope is a -4. We can see that right here. That is going to get plugged in for m, as you can see I just did in our formula. We're going to keep it the same because our lines are parallel. They need to be moving in the same exact direction, so it makes sense that our slope is the same. So as we did on the example on the front side of notes, we're going to just clean this up a bit. These double negatives are going to turn into positives because a double negative is always positive. If you look at your steps that we wrote down on the front side, your next step is that you need to get rid of these parentheses. So our slope of -4 needs to be distributed into the parentheses. So -4 times x and -4 times 1 is going to give you -4x minus 4. And then we have one more step. We're going to take that +4 that is on the left side, that y1 term, and you're going to move it to the right side. Well, because it's a plus right now, you need to subtract it out. So here is our slope-intercept answer. Now, if you read the question, it is asking us to write it in all three forms. So what we mean by that is right here, that is your point-slope form. Right here is your slope-intercept form. So the one form we don't have yet is our standard form. If you look up at your paper, standard form, remember, is ax plus by equals c.
So all we really have to do is get our x's and y's on one side and our constant, or our number that doesn't have a variable with it, over on the right side. So if you look here, we have y equals -4x minus 8. So we can just add 4x to both sides. When we do this, we get 4x plus y equals -8. There's a couple of things that you want to check for to just make sure you are in standard form. Number one, is your a value, or your coefficient of x, positive?
Go ahead and check that because it's a +4, so we're good there.
And have we made sure that all of our numbers, a, b, and c, are integers?
We have 4, we have 1, and we have -8.
We're good.
So we're good. So you can see I went ahead and wrote abbreviations for our three forms. We have point slope right here highlighted, slope intercept form highlighted, and standard form highlighted. Those are our three forms for this line. All right, so now let's go ahead and do our last one. The process is going to be the same. The only difference between the problem we just completed and this one is now I'm asking to write a perpendicular line. So again, we need to look at the equation we're given, and we need to be able to identify the slope. If you remember from the front side when we actually graphed these, the lines that were perpendicular had those negative reciprocal or opposite reciprocal slopes.
Or the flipping opposite.
The flipping opposite. So the first thing we're going to do is exactly the same thing we did in the previous problem. You're going to take that x minus 2y equals 4 that you're given, and you need to convert that into slope-intercept form. So the first thing we're going to need to do is move this x over. We're going to subtract that out. Again, the 4 and the negative x are not like terms, so we need to keep them separate. This -2 needs to be moved as well because we want y isolated. So we're going to divide, make sure that negative goes with it. And you can see that a -1 over -2 becomes a +1/2, and then 4 over -2 becomes a -2. So now I have all the information I need to be able to write my equation in point slope form. The point that we are using for our x1, y1 is going to be this 2 and 7. So we're going to go ahead and plug that in for the x1 and y1. And then the slope, here's where you have to be very careful. In the previous problem, the slope that we wrote over here on the right side we used because the lines had to be parallel. Well, this time they are perpendicular, so you need to figure out the flipping opposite of +1/2. So you're going to flip it,
That'd
and
be
then
2 over 1.
and then take the opposite.
-2 over 1.
Okay, so +1/2 would become a -2 over 1, or just -2. So we're going to go ahead and clean this up. We don't have any double negatives, so these parentheses can just basically disappear. And we get an equation in point slope form. I'm going to go ahead and highlight this for you guys right now. This is our point slope answer. Y minus 7 is equal to -2 times the difference of x and 2. The next step is to, of course, distribute to eliminate those parentheses out. So you're going to get a negative 2x and a positive 4 because negative 2 times negative 2. And then the last step to get into slope-intercept form is to get y by itself by adding 7 to both sides, giving us a slope-intercept answer of y is equal to negative 2x plus 11. That is our slope-intercept answer. Here is our point slope, so the only one we're missing is standard form again. And as Mrs. Netz said, our x and y need to be on the left side of our equal sign, so we need to move this negative 2x by adding it. And then we just need to double check our criteria for standard form. Do we have a positive a term? Do we have our a, b, and c are integers? So 2 is positive, we have 2, 1, and 11, so our standard form is good to go. Some things to think about. This can be a little bit more difficult when there are fractions like there were on the front side, so just make sure you're working with your fractions correctly. If for some reason your a term is a negative in standard form, you would just simply distribute a negative into every term to change every term's signs. If for some reason there is a fraction, you would just go through the process of eliminating that fraction out. And that is linear equations with parallel lines and perpendicular lines. So hopefully you guys feel confident in writing your equations in these three forms. If there's a single form that is making your life miserable for some reason, please reach out to one of us or both of us if you need to. We can be reached on Remind or the emails you see on your screen.
Hey, Mrs. Weigel.
Hey, what, Mrs. Netz?
You know, parallel lines have so much in common.
Do they?
Yeah, it's a shame they'll never meet.
Oh, that's so sad.
Yeah.
All right, well, it's been a pleasure. We will talk to you again in 5.2.